All right, in this video we're going to talk a little bit about the second type of conic sections, and that is, in this case, ellipses. So we'll talk about the definition of an ellipse and then the formula that generates the ellipse. So the difference here is if you look at this big old general, which is where we started the conversation about parabolas in the last section, a parabola had either a y squared or an x squared. An ellipse is going to have both an x squared and a y squared, and both of them will be positive values. You'll see that differs from the thirds to the third type, which is hyperbolas. But basically, an ellipse is defined as having both an x squared value and a y squared value. So let's real quick take a look at how to create an ellipse. So what you can see is you have this, colloquial term called an oval, and they're a little bit different. But an ellipse, basically, what's going to happen is you have these two green points that are called foci or foci, whatever, and then you have these two red lengths, which the sum of the two red lengths will always add up to one another, or to the same thing as you go around this ellipse. We're going to do a little demonstration in class with these twin foci and creating an ellipse. But basically, that's in essence how to create an ellipse. But really, the more important things, the more interesting things, is to define an ellipse this way. You can read this formal definition, but basically in that construction on the previous slide, this distance of those two red line segments coming out of that foci, the twin foci there, the two foci, those two distances, D1 and D2, will remain constant as you go around. So in other words, if you pick any random point on this ellipse and draw it and connect the two distances from there, they will be the same no matter where you pick on the ellipse. So those two things will be the same regardless. Okay? Now, when it comes to points, you can draw a line through the two foci. That's known as the major axis. It's the longer of the two axes. Could be vertical, could be horizontal, depending upon how the ellipse is situated. Perpendicular to the major axis is the minor axis. And the minor axis and the major axis, the axes in general, are perpendicular to one another. The center is going to be the midpoint between the two foci. And the vertices, this would be known as the major vertex. The vertices are the endpoints of the axes. So this is a major vertex, this is also a major vertex. And then the ends of the minor axis will obviously be known as the minor axis, the minor vertex. So the endpoints of the major axis are the major vertices, the endpoints of the minor axis are the minor vertices, the intersection of the two axes is the center. So you got a lot going on here, a lot of things to be precise with. So let's take a look at the way the actual equations of these ellipses look. So let's first start off with a horizontal ellipse. Now, horizontal, it gives it indicates the direction of the major axis. So the major axis is horizontal in this particular case. You can see it in red. And so that means the minor axis will be vertical. Pretty straightforward. Now this is the general form of the ellipse. You can see it shares some characteristics with the parabola general form. You've got H and K, which make your center. But then you've got A's and B's and that kind of stuff. And basically, each number in this general form contributes in some way. So what you'll see is from the center, HK, you would add this A value. By the way, before I get too far into explaining this stuff, if you look at the formula on the next slide of the vertical ellipse, basically a vertical ellipse is saying the major axis is vertical. The big difference between the two is the A value in this case is underneath Y. The A value in this case is underneath X. And the thing to keep in mind is that A is defined as being the bigger number. So A is bigger than B, A is bigger than B. So when you see these numbers in the denominator, the larger one indicate if the larger one is under y, it's vertical, it's bigger in the y direction. If the larger one is under x, bigger in the x direction or horizontal. So once you determine all those things, you can come up with all these little components of the ellipse. So what happens is you can take this center point and both add and subtract the a value, this value right here, to get to the major vertices. So what happens is this distance right here is a. This distance is a. So in other words, you're starting from the center, adding a to get the major vertex, subtracting a to get the other major vertex. Then you would go to the b value and add it to the y coordinate. So what you get is this distance is b. This distance is also b. So the distance between the center and the minor vertices is b. And then the foci has this calculated value c. You use it's similar to the Pythagorean theorem. It is not, however, the Pythagorean theorem, so don't confuse that. You use a and b to calculate this value c, and the c value is added also to the x coordinate here. So the distance from the center to the focus is c. The distance from the center to the focus is c. So that's a little confusing. I hope you can see the symmetry there. So to keep it a little cleaner looking, I'm going to delete this side and the bottom just to generalize. The distance from the center to the focus is c. The distance from the center to the major vertex is a, and the distance from the center to the minor vertex is b. The same thing holds true for a vertical ellipse. Just notice some of the values switch places in the formulas. So for instance, you're adding the a to the y coordinate of the center, whereas in this one you added it to the x. That just represents the differences between things being oriented vertically and things being oriented horizontally. Okay, so there are still a few other things that we haven't yet talked about in this set of formulas. We talked about the length of the major axis is 2a, the length of the minor axis is 2b, and then the last thing that we haven't yet spoken about is this whole idea of eccentricity. Eccentricity of an ellipse is basically measuring the off-centeredness. What it is you make a fraction of the c value and divide it by the a value. And so the closer you get to 1, you get to be very, very oblong. In other words, the c value is big when compared to the a value. Whereas the closer you get to 0, the more circular it is. And by way of a visual demonstration of that, look at a few different ellipses. We can compare. So this is C, and this is A. So if you do C over A, eccentricity is C over A. This is probably a fraction pretty close to 1. Whereas if you looked at the third one in the sequence, this here is C. And this here being A, this one is probably close to 0. So this one would be close to 1, rather oblong. This one would probably be close to 0, rather circular. And this one right here is a circle. So the C value is 0. And this is a circular ellipse, not even a circular ellipse. It is a circle. So as eccentricity gets close to 0, you get close to a circle. It will never actually reach 1 because the focus and the vertex can never be in the same location. But basically, the more and more long you get, the closer and closer your eccentricity gets to 1. So as you can see, there's a lot of things to consider when talking about an ellipse, which means a lot of care needs to be taken when it comes to an ellipse. So just as a means of review, we talked about this one a lot. Let's just make sure we label them on this one before we forget. So This value right here is C from the center to the focus. This distance right here from the center to the minor vertex is B. And this distance right here from the center to the major vertex is A. Often I will just use capital M for major vertex. Often I will use lowercase m for minor vertex. If you are in any way into music, major chords are written with capital M, minor chords are written with lowercase m, so that kind of shines through in my notation there. So in case you're ever curious about that, make sure you ask. So there is the overview of ellipses. The big thing is to be determining whether you're vertical or horizontal and then going from